Cool, let's go ahead and get started. So today we're going to be continuing this, but we're going to do some slightly more challenging questions. And I kind of mentioned this yesterday, how sometimes you'll have a graph like this example. So we'll do this example, and I believe the next one also has a graph. But from then on out, we're going to be doing problems where there are no pictures, no graphs. Everything is going to be purely mathematical. Okay, so it's going to be a little bit more challenging, but we're still doing the same exact thing. We're still going to be calculating slopes and trying to figure out if it's the specific type of shape. So starting with this question, let me zoom in a little bit. And what you can do, actually, I want to see if this works with the annotation tool.
Yay.
Try it out. See if we can place those 4 points where they belong using the annotation tool. All right, Perla's got one of them.
How many am I supposed to do?
Give someone else a chance to do some of the
Okay.
others.
Let me delete one.
And label whichever one you put down. So that pink dot, which letter is that? Okay, we got -4, -2. I see C, 1, 2. That blue dot.
Oops, my bad. I messed up.
Okay. That blue dot, I'm not so sure about. So whoever put that blue dot, look again. Tyrone, yes, you can go again. There you go, Alejandro. Okay, I see my A, I see my C. We're missing D so far. Who's got D? Tyrone, do D. Good, there's D. Okay, so let me go ahead and connect the dots. And before we do the slopes, what does this look like it's going to be?
Hi, Miss Lopez.
Oh, hi.
Oh, wait. Oh, there we go.
Hi, now I can see you. How are you?
Here to check on your babies up here. Well,
Yeah,
young people, I'm sorry. Check on your young people up here.
They're doing good. We are working on our parallelograms.
All right, I see. Do like that.
Okay, guys. So here's our shape. So what do you guys think? What does this look like? Alejandro says it looks like a rhombus. What do we
I
think?
think it's a parallelogram.
Okay, so do we agree that it's most likely at least a parallelogram? Okay, but remember, parallelograms could be squares, rectangles, or rhombuses. So what is something that we can check to maybe figure out, I mean, what can we get rid of? What can we definitely get rid of? Yeah, definitely not a square. Definitely not a rectangle. And then from there, what can we check to figure out whether or not this is a rhombus? What are a couple of things I can check for?
We can check maybe the slope to see if the diagonals are perpendicular, because if they are, then it's a rhombus.
Good. So diagonals have to be perpendicular. And let's also just make sure that we do in fact have a parallelogram. So let's just make sure that we have two pairs of parallel sides. Okay, so let us begin with the parallel sides. So for example, I can check to make sure, check and see whether AD is parallel to BC. If they're parallel, what has to be the same?
Their slopes.
The slopes must be the same. So go ahead and check the slope of AD, I mean, and check the slope of BC.
For AD, I got 4.
Good. So did Alejandro. He actually beat you to it.
Sadly, but it's okay. It's nice to see other people participating.
That's very true. And what about the other one? BC. Is it also? Oh, and Alejandro says BC is also 4. Okay, I see now. So yeah, they're both 4. So we know that it's definitely a parallelogram, but now we have to check whether it's specifically going to be a rhombus. So if it's going to be a rhombus, like Perla said, that would mean that the diagonals are perpendicular. So can somebody tell me what the diagonals are in this case? Oh, oops. Sorry, guys, it just died on me. Okay, now I have to line.
It's funny how we can still see the little, whatever that is, parallelogram or rhombus.
I know, because the annotation tool is like separate. Okay, there we go. All right. So what are my diagonals? We're looking at AC versus DB. And we want them to be perpendicular. So what should the slopes be? What do we want those two slopes to have?
Opposite reciprocals.
Opposite reciprocals. Good. All right, so for AC, go ahead and calculate that slope, A to C. And let me draw that in so that we can visualize it a little bit better. 4/5. Do we agree? Do we disagree?
1, 2, 3, 4. Unless I don't know how to count anymore. But I got 4/5.
Does anyone agree, disagree? Oh yeah, Alejandro, no, we're not doing AB, we're doing AC. And I see that you wrote it in there. Yes, so it goes 4 up and then 5 across. So yes, we have 4/5. What about DB? Count carefully.
I think I got 1, but I don't know. I think that's wrong. Never mind.
Would anyone else like to double check? Alejandro says 5/3. So
I got 5/3 too.
Let me clear some of these drawings so that, or erase some of them so we can kind of like see it a little bit better. Okay, here we go. -5/3. Yeah, from D to B, which I accidentally erased, it looks like we go 1, 2, 3, 4 down, and then 1, 2, 3 across. So it's 4/3, -4/3. So what's going on? Are these perpendicular?
No.
No, ma'am. No, ma'am. At first it looked like they were, didn't it? Yeah, it looked like this could be definitely a rhombus, but unfortunately, since these are not perpendicular, it's not. It's just a regular old parallelogram. Oh my goodness, my technology is not happy today. There we go. Okay. So any questions on this one so far?
No.
So do we see why it matters to just be absolutely sure?
Yeah.
Yeah, it's worth it to do the math.
It's true because when I was doing the Khan Academy yesterday, I tried to do it without doing the math,
Mm-hmm.
and that went wrong because I didn't get 100 any time, and I
Oh,
tried it 4 times. So
yeah. It kind of sucks sometimes, but you just got to do it. You got to keep pushing through. Luckily with Khan Academy, you can do it as many times as you want. So it kind of like, you keep understanding it better every time. Okie dokes, let me clear this board so we can do another one. All right. So here we go. Here's a slightly different one. This time we are asked to find the point that makes it a rhombus. So let's begin by, again, go ahead and annotate and put in the 3 coordinate points that we have so far. Okay, good. There's A. There's B. Good, Tyrone. Who would like to do C? Someone go ahead and put C into there. 7, -5. Go ahead, Tyrone. Count carefully, Alejandro. I think you went to 6, -5. It's 1 more over. There we go. Good. Okay, awesome. So there's our 3 points, A, B, and C, and we want this to be a rhombus. So again, what are the criteria that we need to meet in order for this to be a rhombus?
okay, we need to know that the diagonals are perpendicular.
Mm-hmm.
It needs to have one, at least, no, it's 2 pairs. I don't remember. I think 2 pairs of parallel sides.
Mm-hmm.
Let me check my notes for the rest. I don't remember off the top of my head.
That's okay.
And it needs to have 4 congruent sides.
And 4 congruent sides. Good. Okay. Alrighty. So I see that somebody already put a point in there, and that point looks like a very good candidate to me. Nice job, Alejandro and Jalen just got in there. So you guys are actually doing what I was going to tell you guys to do. We're going to test a point and see if it works. So it looks like they chose, what is that? 1, 2, 3, 4, 5, 6, comma, -1. I hate when they don't put numbers. It's like so hard to count. So we've got 6 comma -1, and we're going to test just to make sure that we are fitting all of our criteria. So tell me, if we've got parallel sides, what needs to be true?
Um,
Hold up, who chose answer B? That's 6 comma +1. Be careful. Okay, so
wait, I'm
so
confused. I think I'm overthinking it because it just has to be parallel. Like, I don't know.
okay, so 6 comma 6 comma -1. Okay,
This is a mess.
this is such a mess. So here's C, and this is D. Okay, so which sides have to be parallel? If this is our answer, which sides have to be parallel? Anybody?
So AD has to be parallel to, what is that point? The OB. B B.
Yeah, so AD has to be parallel to BC. BC. So we can check that.
Ms. Lopez, can you clean up those letters, please?
Yeah, I'm on it. I'm on it. I got you. We've got a whole mess over here. If you're counting slope, that's fine. Just do it without annotating because it kind of makes everything a little messy. Okay. So I believe this was B, and then this one is D. Okay, so let's just make sure that our slopes are in fact parallel. So what is the slope for AD?
1/4.
Close.
Oh, -1/4.
Mm-hmm. So we're good with that. We've got our parallels. And then what are my diagonals that must be perpendicular?
BD and AC.
Good. BD must be perpendicular to AC. So go ahead and check the slope for BD and for AC. And let me draw that in as
I
well.
got 1 for BD.
For BD, you got 1? Let me check.
I got 3/3.
1, 2, 3, 1, 2, 3. Good. And what about AC?
I got 5/5 or 1, 2.
Or 1. Good. I think, Perla, you got them backwards again. So 1,
Oh.
BD is +1, and AC is -1.
You see, I have problems counting, miss. I'm sorry.
I think, yeah, I don't know why you keep making that same exact like mistake of going positive when it should be negative. So let's just like focus on that today and make sure that you don't keep making it, okay?
Tyrone.
Okay.
Oh my god.
So we are good to go. You guys are going all crazy in here, so I can tell that you're like, Miss Lopez, we get it. We get it. Move on to the next question. All right, but do I have any questions on this one? Okay, cool. All right, so Now, and let me erase all this. Now we are going to have no pictures, no pretty pictures, no graphs, nothing at all other than the coordinate points. So we're going to have to implement a slightly different strategy for these types of questions because we don't have a nice picture in front of us, can't really do anything. However, we are given coordinate points, so that's a little bit helpful to us in a lot of ways. What we can do, anytime you have a problem like this one that doesn't have a graph or a picture, we know we're dealing with a quadrilateral, right? We know that. So something that we can do is just begin by making a little picture in your notebook of a quadrilateral. Doesn't have to be anything fancy, just put a square or a rectangle and label it. With the correct labels. So we've got E, F, G, and H. Now it doesn't matter that our quadrilateral might look different than the actual quadrilateral because the only reason I'm using this picture is to visualize what we need to either calculate or what might help us eliminate some answer choices in order to get the right answer. All right, so the first thing that we can do is, out of all of our answer choices, what is something I can check for in order to possibly eliminate one or two answer choices? Okay, and Alejandro, figuring out the distance is a really good idea, but we're not going to learn how to do that until Friday. So table that for later. So right now we're thinking, only think about slope right now. Thinking about slope, what could I compare and possibly see in order to eliminate some answer choices?
Coordinate points.
Yes, we have coordinate points.
Well, obviously, I'm dumb, sorry.
Think about slope. Which slopes could I calculate?
Maybe to see if it's a rhombus, but I feel like we've been doing that this whole time, so that's probably not the answer.
It could work. Okay, let's do this. Out of all your answer choices, which two have something in common?
The
Rectangle and
rhombus.
rhombus. What do they have in common?
That they are not squares.
Okay, what would make them a square?
Congruent sides and 90-degree angles.
Congruent sides and 90-degree angles. Good. Which of those can I check using slope? Can anyone help Perla out? Okay, so bear with me. Here we go, one more time. The strategy that we're using right now, what we're trying to do is get rid of an answer choice, okay? So here's the question, which answer choice, how could I eliminate square, for example? What would I have to check for in order to eliminate square? If this is a square, what does it have to have? Right, it's got to have 90-degree angles. That would make it a square, correct? Well, it would make it a rectangle, and then maybe that would be a square. But it definitely has to have 90-degree angles if it's a square or a rectangle. So what we can do is check those angles out, see if they're 90 degrees. And if they are 90 degrees, I would be able to get rid of A and D. But if they're not 90 degrees, I could get rid of B and C. So checking the angles is going to work out for us. So how do I do that using slope again? 90 degree means what?
Perpendicular?
Perpendicular. So we're going to check, is EH perpendicular to EF? But in order to do that, I have to calculate my slopes. So E is -7, 3, and H is 2, -6. How can I figure out that slope using my coordinate points?
We can do y2 minus y1 over x2 minus x1.
Very good. Okay, so using those two coordinate points, -7, 3, and 2, -6, let's plug that into our slope formula and see what we get. So what would I write down for y2 minus y1? 3 minus -6. Good. Oops, -6. And then x minus x1, -7 minus 2. Thank you, Tyrone. Let's do the work. So 3 plus 6 is 9. -7 minus 2 is what? That would be -7 plus 2. -9. Good. And 9 divided by -9? Move this all over. -1. That's correct. -1. So we get -1. Now let's check EF. We already know E is -7, -3. F is -4, 6. So same idea. Let's go ahead and plug it all into the formula. What do I plug in? For E and F.
For E and F?
Mm-hmm.
6. Oh, wait, we already did that though.
No, we did E and H.
Oh, wait. And why did you put? Oh, my bad. Sorry. Okay. So for E and F, it would be 6 minus 3
Mm-hmm.
over -4 minus parentheses -7.
Good. All right, what's 6 minus 3?
3,
And -4 plus 7?
3,
3. So we get
1.
1. Do I have perpendicular slopes?
No.
No?
Oh, yeah. Oops.
Yeah, we sure do, because this is 1 and -1. So far we know about one right angle for sure. What other right angle, or what other of these angles should I check next? Should I check F, G, or H?
What about G?
Yeah, that's a good idea. Let's check out G now. Okay, so can I erase the work for what we've done so far?
Yeah.
Okay. And actually, let me write this in here. So this slope was -1. This slope was 1. So now let's check G. So we would have to make sure that FG is perpendicular to GH. Let's find out if that's true. All right, so FG, I know that G is 5 comma negative 3. Slope for FG, what am I plugging into my formula?
I'm going to speed this, Miss Lopez. Negative
All
3
right.
minus 6 over 5 minus parentheses negative 4, which equals to 5 plus negative 4. Oh, wait, no, 5
5
plus
plus
4, my
4.
bad.
Yeah. All right, so what do fill in these blanks? What do I get?
Negative 9 over 9.
Which is?
Negative 1.
Negative 1. So this is negative 1. And now the last one, GH.
Sorry, my space bar wasn't working. That's going to be negative 6 over, negative 6 minus 3. Minus parentheses
Minus.
negative 3.
Mm-hmm.
Oh, God. And then over 2 minus 5.
Okay. Negative 6 minus negative 3.
Wait. Oh, okay. Negative 6 plus 3 is negative 3.
Good.
Over negative 3.
Which is
1.
positive 1. So here we got all our answers. Let me move this. Okay. So it looks like we've got 2 pairs of parallels as well as all the angles are going to be 90 degrees. So what can I get rid of?
A and D.
A and D. Very nice. Now, finally, we have to check. We need to figure out whether this is a square or not, because it's definitely a rectangle, but it might also be a square. So what is one more thing I can check using slopes? Because so far, the only thing we've confirmed is that it has all 90-degree angles. But there's one more thing that makes a square that we can check using slopes. I know you want to check the distances, Alejandro. I know you do, but we can't right now.
A square. Oh, wait, never mind.
Just wait till Friday, Alejandro. I promise you, you'll get to do the distance. I don't think any of you want to do the distance formula right now.
Oh, the distance formula. Yes, I like formulas.
Well, we'll get to it on Friday. But for now, we're trying to only use slope to figure out our answers.
I'm trying to remember it, but I can't. Okay.
So squares have all 90 degrees. And remember, a square is the combination of a rectangle and a rhombus. So what's something that a rhombus has that we actually checked in the previous example?
What was the question?
So what can I check about this quadrilateral that involves calculating some slopes? We already know the slopes of all 4 sides. What is one more slope that I can calculate? Yeah, Jalen, I can't check the distance of the sides because we're going to need the distance formula, so I'm going to wait till Friday on that. We're not quite there yet. What do we know about the diagonals? What do we know about the diagonals of rhombuses and squares? Good, they are perpendicular. So that's the last thing that I can check. I can look at my diagonals and see whether or not I have a 90-degree angle. So now we're checking to see if EF, or not EF, EG is perpendicular to FH. Okay, so that's our final check. So let's go ahead, same thing, using the slope formula. What do I plug in for EG? Perla, stop confusing everyone with your formulas, girl.
No, I'm trying to answer the question. Okay, so we're trying to find the slope, right?
Yep.
Okay, -3 minus 3 over 5 minus parentheses -7. 5 plus 7.
Okay. What's -3 minus 3?
-6. 5 plus 7 is 12.
And -6 divided by 12?
-2.
Nope.
Oops. Oh my god.
Perla can't do math, confirm.
What is it?
-1/2.
-1/2. Good. That's EG. Now let's check FH. What do I plug in here?
FH, -6 minus 6 over 2 minus -4.
Okay. -6 minus 6.
-12.
2 minus -4.
6. Okay, now that's -2.
That's -2. Are these perpendicular?
No, because it would have to be the opposite. The sign would have to flip.
Good. So it would have to be +2, not -2. Therefore, is this a square?
No.
It is not a square, but it is a rectangle. There you go, ladies and gentlemen. That is a long question, you guys. This is how it's going to be. This type of question is not easy. It looks like it might be. I mean, if you have a coordinate plane in front of you and you can graph it, awesome. But we don't. So we have to do it mathematically, and you have to know how to do this mathematically, especially for the next topic test that you guys are going to be taking.
Ms. Lopez, can I tell you a secret? You're probably going to be disappointed in me.
Mm-hmm.
On the algebra test, they had us do something like this.
Mm-hmm.
And what I did was I went to the coordinate plane from another question and I grabbed the point.
That's illegal.
No, it's smart though.
It's not illegal because guess what? On your sheet of paper, you actually have a
Wait, what did she do?
I like the question didn't have a coordinate plane and I didn't know how to do it. So I went back to another question that did have the coordinate plane and then I graphed the points on that and
It's
then
illegal. Stop cheating. I'm reporting you. Get banned, noob.
No, because part of what you get on the EOC on your little yellow packet thingy, you on the back of it there was a coordinate plane. There was something that you can graph on. So technically that's fine. All right. So any questions on this problem? Let's do another one that's very, very similar. Except I'm running out of room, so hopefully I have enough room. This quadrilateral has those 4 vertices. Which statement is true? So first, let's actually read through the statements and see if they even make sense, because sometimes the statements don't even make any sense, so we can already get rid of some answer choices. So can I have a volunteer read statement A?
I'll read since nobody wants to read.
Okay, go ahead.
Okay, I'm gonna start losing my voice, but okay. Quadrilateral RSTU has vertices 1, comma 3, 4, comma 1, T, comma I'm T 1, comma -3, and -2, comma -1. Which statement about the quadrilateral RSTU is true?
Okay, statement number A. Since the diagonals of the quadrilateral RSTU are not congruent, it is not a rectangle. So does that make sense? Do rectangles have congruent diagonals?
No.
If you're ever unsure of it, draw one out just to
Okay.
check.
Wait, yes?
So on my rectangle, would these diagonals be congruent
Yeah,
in
because
length?
it's supposed to be 90 degrees.
Yeah, so the diagonals should be congruent. So this statement makes sense, so we can keep it. Statement B. Since the adjacent sides of the quadrilateral have equal slopes, it is not a rectangle. What does adjacent mean again? Ooh. What does
I wrote
adjacent
my
mean?
answer.
Next to. Oh, I just saw it. Sorry. Yes, next to. If the adjacent sides had equal slopes, what would that make them?
Parallel?
Parallel. So would you even have a quadrilateral in that case?
No.
No, you would kind of just have like one long line. So that might not really make sense. This one's kind of a question mark. C, since the diagonals of a quadrilateral are congruent, it is a rectangle. So that we already know that should be true. That makes sense. Since the adjacent sides have equal slopes that are negative reciprocals, it is a rectangle. That makes sense. So what does it look like we have to check? We've got to check the slopes of the adjacent sides, and we need to check the diagonals. So there's kind of a couple things we got to check. Well, this is very similar to the previous problem. So I'm going to go ahead and I don't know where this is on. I don't have a graph. I'm not graphing it. I'm just drawing a little diagram and labeling it with the correct letters. So R, S, T, and U. And R is 1, 3. S is 4, 1. T is 1, -3. I mean, wait, sorry, I put that in the wrong place. 1, -3, and -2, -1. Okay, here are my 4 corners. Now let's check which of these answer choices can I check? I can check answer choice. Which one has to do with slopes?
B and D.
B and D. So these are the ones I can check. A and C, I can't really check without the distance formula, so we'll have to do that on Friday if possible. Okay, here we go. Let's start by checking, well, they're both talking about the adjacent sides. So what 2 sides can I check that are adjacent? Someone give me 2 adjacent sides.
RU and ST.
RU and ST, those are opposite sides. Those are not adjacent. So what's a pair of, so ST and TU. Okay, there we go. ST and TU. We're going to check their slopes in order to figure out what type of relationship they have to one another. Okay, so go ahead. Now I want you guys to try this on your own. Using the slope formula, figure out what is the slope of ST and what is the slope of TU. plug those numbers into the slope formula and see what we get.
Wait, do you want us to share it when we get it or just?
I'll give everybody about 2 minutes right now. So if you already have it, great, but let's give everyone else a chance to do it as
Okay.
well.
Sounds good.
All right, that was 2 minutes. So let's see, what did we get for the slope of ST using the values that we are given? Perla, don't give away the answer. What is the slope of ST? Alejandro. We're gonna have to have a conversation, Alejandro. That is inappropriate. Okay, Jalen, I'm gonna wait for at least one more person to give me an answer. So I'll reply back to you in a moment. Okay. Anybody else? So far only Perla and Jalen did the math. That's it. I don't know about you guys, but if I were you, I would try this out on my own, and if I ever want to pass the EOC. I mean, if you're just going to sit there and let other people do the work for you, then what are you going to do when there's a test? Emily, what numbers should I plug in to find the slope of ST? -3 minus 1 over 1 minus 4. Good. 1 minus 4. Tyrone, what is -3 minus 1? What is -3 minus 1? Good, -4. Daniel, what is 1 minus 4? Daniel, 1 minus 4.
-3.
-3. So my final answer, my slope is 4/3, 4/3. Now, same thing for TU. So we want to see what type of relationship we get. It might be parallel, it might be perpendicular, it might be something else, but we have to figure it out in order to get our answer. So for TU, I'm just going to go ahead and do this one because I don't want to spend all my time calculating slope today. For TU, I can do, okay, Tyrone, that's fine. Tyrone, that's x1 and x2. So remember, we do y1 and y2 first. So -1. Okay, let's do it this way. My t is going to be my y1 and my x1, and u is going to be y2 and x2. So this is going to be -1 minus -3 over -2 minus 1. -1 minus -3, Janelle's, what's that going to be? Remember that two negatives make a positive, so that's really -1 plus 3. Okay, that's 2. Thank you, Emily. And yes, Tyrone, what's -2 minus 1? -3. -2 minus 1 is -3. So we end up with -2/3. Now, are these perpendicular? No, they are not. They are not perpendicular. Are they equal? They're also not equal. So it's neither B nor D. And unfortunately, we can't actually check A or C right now because they require the distance formula. So we're not actually going to get the full answer to this question today, but I think I'll come back to this one on Friday and we can finish it. But at least we were able to get rid of 2 answers. Okay, here's another. We're just going to be doing a few that are just exactly the same steps, okay? So one more time, we have a quadrilateral. We don't know what it looks like. We're just going to draw any old rectangle. And then later on, we'll figure out what it actually is. But here we have A, B, C, D. A is -2, 3. B is 4, 5. C is 10, -1. And D is 8, -9. Okay, and then it says let E, F, G, and H be the midpoints. Okay, so we've got some midpoints too. E, F, G, and H. And we'll see if that matters. And we want to know what type of quadrilateral do we have. Okay, we've already know some strategies. What are some things I can check in order to eliminate some answer choices? No distance formula. No midpoint formula.
That's the midpoint.
Yeah, no midpoint formula. We're going to try and do this using only slopes. Yeah, let's check to see if we have any 90-degree angles. So Tyrone, since you suggested it, tell me which corner do you want to look at first? C? Okay. So let's check to see what type of angle is angle C. So we're trying to look at BC. We're checking BC compared to DC or CD. All right. Let's get to it. Let's actually, at this point, I want it to be nice and quick. So we're going to do this together. BC, what do I plug in for my slope?
-1 minus 5 over 10 minus 4.
-1 minus 5 is,
-6 over 6.
so I get,
-1, yay!
yay. Okay, good, nice and quick. What about for CD? C and D, what's y2 minus y1? -1 minus -9. And then 10 minus 8. Very nice. -1 minus -9. Oh, I see it. 8 and 2, which ends up being 4. Do I have perpendicular angles? I do not. So what can I get rid of right away? It's not a square. Jalen, that's so rude.
So it's not, oh, never mind. You already crossed it out.
Yeah, so it's not a square and it's not a rectangle. But what can we check to see if it's a rhombus?
Perpendicular diagonals.
Perpendicular diagonals. Let's go ahead and do that. Now we're checking AC and DB. For AC, three minus -1, good. Over.
Wait, isn't it the other way around?
It can be either way, Perla, as long as you're consistent. So if you're doing 3 minus -1, you have to do -2 minus 10.
Okay, thank you.
You're welcome. And so what does that give me? Four over -2 minus 10. Good, -12. What is that simplified to? Four over -12 simplifies to, yeah, 2 over 6, which is also 1 over 3, -1 over 3. Okay, cool. Now dB. We're almost there. So -9 minus 5 and 8 minus 4, good. We're getting the hang of it. -9 minus 5. -14 over 4. Does that give me what I'm looking for? What does that simplify to? Good, -7 over 2. Are these perpendicular? No, so it is also not a rhombus. Therefore, it is simply a regular old parallelogram. All right, you guys are getting it now. Do we see the process? We always basically have to check if the corners are perpendicular and if the diagonals are perpendicular. And that helps us to narrow it down to figure out our final answer. Questions so far? Okay, I believe I have at least one more. Yes. So this one, again, very, very similar. Now I want you guys to try this completely on your own. I will draw the diagram for you, but get into the habit of doing it in your own notebook as well so that you have it and you can reference it on your own. The most important part when you make your diagram is to make sure you're following the order of the letters. So if this is MNOP, you gotta go around in order, MNOP. Okay? Because if you switch the letters around, that's gonna mess you up. All right, so M is -1, 1. We got 1, -2, 5, 0, and 3, 3. So go ahead and do exactly what we've been doing. Check all of those different criteria and see if you can figure out what type of quadrilateral we have. Yeah, on your own completely. Get started on your own. I'll give you guys about 3 minutes to start and maybe I'll add more time. And if you want me to check any of your answers, you can put them in the chat. Okay. I'm checking your answers if you've put them in the chat so far. All right, about 1 more minute. At least try to get rid of one answer, if not two or more. All righty. So can anybody give me something to eliminate and why?
C and A.
B and A or
C.
C and A?
C and
Okay,
A.
so
Check.
how can I eliminate A? What did you check for?
For perpendicular diagonals.
Perpendicular diagonals. Now, perpendicular diagonals are a good check for rhombuses and squares, not for rectangles. For rectangles, it's something
Oh
else.
yeah, you're right.
What do we check for rectangle?
90-degree angles.
Good, 90-degree angles. And so I'm assuming that you checked the sides, the four sides. What did you guys get for MP? What's the slope of MP? Anyone? Good. -2 over -4, which simplifies to 1/2. What about the slope of MN? What did we get for MN? Or PO? Either one.
For MN.
Mm-hmm.
Sorry.
It's okay.
-3 over 2.
Good. -3 over 2. So we already know that MN is not perpendicular to MN, or MP, I mean. So it's definitely not a rectangle. Then, what else can we check? So in order for it to be a rhombus, what has to be true? For a rhombus, what has to be true?
The diagonals have to be perpendicular.
Good. That diagonals have to be perpendicular, so we have to check the diagonals. What did you guys get for MO and PN?
For MO, I got -1 over 6.
Mm-hmm.
PN is 5 over 2.
5 over 2. Are those perpendicular?
Definitely not.
Definitely not. So we also know it's not a rhombus. And then between a trapezoid and a parallelogram, how do I decide the difference? What has to be a parallelogram?
It has to have at least, 2 pairs of parallel sides.
2 pairs of parallel sides. So we got to check our last two slopes and see if they match. So what did you guys get for PO?
I was about to do NO.
Did anyone already do it?
0, okay, -3
Mm-hmm.
over 2.
Mm-hmm. So far we have one pair of parallels. So these two are the same. And then for NO, you also should get 1/2, which means the other two parallels also match. So we do
Yay.
have a parallelogram. So it was D. All right, so it's a long process. It's worth going through it the whole way through. Tomorrow, guys, I'm actually going to be absent tomorrow, but I will put up some work for you guys to complete. It will be graded, so please make sure you do complete it during class because it is mandatory and it will be graded. All right, so good job today. I will see you guys not tomorrow, but on Friday.
Okay, bye, miss.
Bye.
Bye, miss. Have a great